Hi everyone, I wanted to take some time to show you how to start and end a chi-squared test because I think there are some aspects of our chi-squared test, if you open the PDF, that you can kind of figure out on your own, but I've had enough students ask questions that I think it's important to help you out on a few things. So to start our chi-squared test, we do need to go into our data set, and we have analyzed in categories. We've split up our data into two categories, or for some of you, three categories, and you've done your statistical summary table, and you've done your box and whisker plot using those. So the way that we're going to set up our chi-squared test is by putting our categories into an observed values table. So I have category 1 and category 2. It doesn't matter if that's your rows or you put them up here in your columns. Then the way that we're going to split up our data is by seeing if one of the categories has higher values than the other category. So what we're going to do is we're going to get the overall middle value of all of our numerical data. So we're going to make sure to find the numerical data that we used for our statistical summary table and our box and whisker plot. So for me, it's in column F, and we are going to get our overall median of those values. So I made sure to only highlight F2 to F31 because there were some data points that I had eliminated from my study because they didn't fit either category. And then after I have my overall median, I'm going to set up my other area to have one column that is less than the overall median and one of them that's greater than. And then all I have to do is count. Now, remember that we have a shortcut here of being able to count easily. And so if you highlight your data and go to data, sort range, ... you can say, please take my header row if you've labeled your headers and sort it first by your category, so that's band or solo artist, and then by your numerical values, which for me is my claim sales, column F. And then what that does is it sorts those least to greatest, so they're easier to count. So I'm looking for how many bands had less than the overall median of 32. So this is 32, so it actually starts here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there were 9 bands that have less than the overall median. There were also 1, 2, 3, 4, 5, 6, 7, 8, 9 that were greater than the overall median. And look at you guys and how this got set up. If I go down here and count, here's 5 are less than and 7 are greater than. It doesn't really seem like the bands had higher values or lower values than the solo artists. All of these numbers look pretty similar. That means I do not have a statistically significant difference, but that's why we're running our chi-squared test to confirm this. So these are my observed values that I now can write in to my document here. Whoops. Oh no, where did those go? In terms of doing your next part, which is the expected values, I will point out that I really do believe that if you look at this closely, you can figure out what the formula is for calculating each box's expected values. So you see that this is a number 31, it came from here, the column, and this is a number 26, it came from the row, and then the 51 is the total. So here is what I want to remind you of next. There is a formula for degree of freedom. So if I type in degree of freedom formula, and I'm going to type in actually rows and columns because we have a particular test going on. So here's a formula. It's the number of rows minus 1 multiplied by the number of columns minus 1. So if we go back to our observed values table, we have a 2 by 2 table. So it will be 2 minus 1 multiplied by 2 minus 1 if you have 2 categories. It will be a little different if you have 3 rows or 3 columns. The next aspect of so you have your degree of freedom, and then you need to find your critical value, because we know that we have statistical significance if eventually our chi-squared values beats the critical value. So the critical value is found online. You could type in chi-squared critical value table, or you could just click on the link provided on the example. So here we go, we have a degree of freedom of 1, and then in order to publish a study, we have to be 95% confident that it wasn't due to chance. And these values up here are the percent due to chance. So I'm going to find 5%, 100% minus 5%, and I see that my critical value is 3.841. This will be true for any 2 by 2 table because for all of us. We want to publish a study at a 95% confidence level. Going back to, so now you know how to do the degree of freedom and the critical value. If you're a full IB candidate, you will want to do your chi-squared Yates by hand, but otherwise you can go down to this box and we're actually going to get our chi-squared Yates value online. You can type in a chi-squared online calculator into Google, or you can just click this link and it will bring you to a chi-squared calculator. And I'm going back to my observed values and I have 9957. So on here, I'm going to put in our observed values, 9957. 9, and I'm doing a chi-squared Yates, and I can press calculate, and now it will give me that my chi-squared value is 0.006. So I'm going to go into my task 4 and make sure that I type that in. Okay, so there's my p-value, and I also need to type in insert equation, my chi-squared value, chi-squared, and actually I want to do some subscript because this is Yates. There we go. Subscript, Yates, and that is equal to 0.006, and my p-value is equal to 0.9405. 0.9405. Okay, and then I would like to, just like our example did, I will want to cite my source and provide a screenshot of that. So I can type in from and then paste in my link. And I can take a screenshot. If you have a Windows, it will be, there's like a scissors tool or something. You can Google how to take a screenshot on Windows. And then what I'm looking for is I'm hoping that I have found statistical significance. In my case, I already knew that I wasn't going to find statistical significance. So just like our example, the saying is if chi is high and p is low, the null hypothesis has to go. Now don't write this on your study, this is just my hint for you. And what we mean by that is chi-squared beats the critical value, and the p-value, p is low, lower than 5% is that magic one that we can finally publish our study, because it means we're more than 95% confident that our findings were not due to chance. Then we reject the null hypothesis. Rejecting means we're accepting that the two category, what would be a good way of putting this? That our categories are related to the numerical values that we're getting. Rejecting, we have found a relationship. Statistically significant relationship. So a friendly reminder from our notes that you either accept or reject the null hypothesis, and you reject if the chi is high and the p is low. The null hypothesis has to go. Otherwise, you will accept independence. You do not have a relationship between the two things. In my case, my chi-squared Yates did not beat my critical value of 3.841. Therefore, I'm going to accept independence. There is not a statistically significant relationship between being a band or solo artist and the number of albums that were sold in terms of all time. So hopefully that gives you some hints on finishing it. I didn't mention what a null hypothesis is, but it is in your math notes, and you can also Google it. So that gives you a hopefully sense of direction on your chi-square test for independence.